Welcome to the Bodhi Academy. My name is Amisha Kalaso, and in today's video we will continue with our chapter squares and square roots. So now in today's video we will learn about the different methods to find the square roots of any given number. So the first method to start with is by finding the square root through repeated subtraction. Now say we are asked to find square root of 80. Okay, so we are asked to find square root of 80. So in this case how we do it is we start, this is 81, square root of 81. Okay, so we begin by taking the number 81, and when we say repeated subtraction we have to start subtracting using the odd numbers that we know. So the first odd number is 1, so we'll get here 80. Okay, now the next number that we get here, that is 80, you have to subtract it with the next odd number, so that is 3. So here we'll get 77. Next we have 77 minus the next odd number, that is 5. So we'll get here 72. Next 72 minus next odd number is 7. So that will give us 72 minus 7. So this is 6, 7, 8, 9, 10, 11, 12. So 5 and so 65. Next odd number 65 minus 9. So 65 minus 9. So 5, 1, 9, 10, 11, 12, 13, 14, 15. So 6, 56. Next 56 minus next odd number is 11. So here we'll get 45. Then 45 minus 13. So we'll get here 2 and 3, 32. Then 32 minus next one is 15. So 32. So this is 15. 5, 6, 7, 8, 9, 10, 11, 12. So 6 and 7, 3. So this is 17. So this will be equal to 17. And after 15, this is 17 here. So 17 minus next odd number is 17. So we get 0. Now how do we find the square root using this method? So we have to subtract till we get a remainder as the 0. So now we count how many repeated subtraction we have done. So we have 1, 2, 3, 4, 5, 6, 7, 8 and 9. So we can say that root 81 equals to 9. So this is how you can find the square root of a given number by repeated subtraction. It may be any number, you have to just begin by subtracting it with the odd numbers. If the subtraction, now in this case you got a 0. In some cases it might continue giving a negative number on the other side. In that case what we can say, that this number does not have a perfect square. Okay, so this was about finding square root through repeated subtraction. Now we'll see how to find square root through prime factorization. So the first one is 6420. So say I have 6420. So now we'll see how to do prime factorization method. So we have to start by simply dividing the given number with the smallest rate. First we have to check its divisibility from the smallest number we know. So that is by 2. So start by 2. Since now this is an even number, it will be divisible by 2. So we go 2, 3s are 6. Okay, then 2, 2s are 4. Correct, and then these two zeros will be here. Next again this will again go in 2 times table. So we go 2, this becomes 3 does not come. So less than 3 which is there, 2. So 2 1s are 2. So what is remaining? 3 minus 2 will be 1. So that 1 goes carry over here. So this number becomes 12. 2 how many are 12? 2 6 are 12. and again this two zeros go over here. Then next again it goes in 2 times table. So we say 2 how many is a 16, 2 8s are 16, and this goes as 0. Next 2 and this 8 is 2 4s are 8, and 0 and 0. Again 2 2s are this 0 and 0. Now 2 1s are 0 and 0. So next we'll have 2, so becomes 5s are and 0. Again 2 2s are 4, 1 goes carry 25. Next now this won't go in 2 times table, 3 times table also it won't go, 4 times no, it will directly go in 5 times table because the number in the units place is 5. So 5 5s are 25, and lastly we'll get 5 1s are 5. So this is prime factorization. Now what you have to do here is that once you get all these values, you have to start pairing them up. So this 2 and this 2 will be 1 2. Okay. Next this and this, this and this, this and this, and this and this. So you have to go like, the statement will be like this. So you have to write root of 6400 equals to, you have to write only these numbers. So 2 into 2 into 2 into 2 and into 5. So we'll have 2 multiplied by 2 multiplied by 2 multiplied by 2 into 5. So that will be, so this is 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 5s are 6 5s are 30, 5 1s are 5, 6 7 8. So 8. So the square root of 6400 is 80. You can even multiply and check. Since 8 into 8 is how much? 64. And because you have this, it's 80 over here, so it will have 2 zeros. So that is 60. So this is the method of prime factorization. Now let's take another example and see. Now the next question is 90 a prime? Is 90 a perfect square? So again we'll start by prime factorization. So this number will again, we can take it in 2 times table. 2 4s are 8, so 1 will go carry. So 2 5s are 45. Okay. Next now this number will go in 9 times table. Sorry, 3 times table. So 3 1s are 3, and this becomes 3 5s are 15. Then again 3 5s are 15, and 5 1s are 5. So now in this case what you see, you are able to get only one pair, that is this. These two numbers are individual. Therefore we say that 90 is not a perfect square because there is no pairing that is happening. No pairs formed. Understood? So if any, by prime factorization, if a number is not able to form pairs of any two numbers, then in that case we can also say that the given number is not a perfect square number. So now next we will learn about how to find square root by a division method. Now this method is quite lengthy, but we'll try. Okay. So first you have to start by basic division. So we start by basic division. So the given number is 5 to 9. Okay. Now the first step is to put the bars on top. So we start from the back end numbers. So end two numbers, we take them together. So we'll have this, and then one number goes together. Okay. Now what you have to do is that the first step. Now usually in division what we do, we start with, if there is 5, then we say it will go directly in 5 times table. So 5 1s are 5. In this case you don't have to do that. You have to start by finding a perfect square number which is either equal to this number or less than this number. Now 5 is not a perfect square number. So less than 5, which number do we have? That will be 2 square. So 2 square is 4. So we can take 4 here. So 2 into 2 will give us 4. Okay. So here we'll get 1. Now you pull down both of these numbers down. So we get 129. Now the next step over here is that this number which is left over here, you have to double this number. Okay. So double of 2 will be 4. So 4, and you leave some space over here. Now how do we find this number? So you have to basically start by 4 and this into this equals to, you have to find a number that is either equal to 129 or less than 129. Okay. Now the number that you will be adding here has to be the same number itself. So if I start with 2, then here also I have to take 2. So you have to do 42 into 2. 2 2s are 4 and 4 2s are 8. So no. So now instead of going on doing this, you have to continue to do this actually. So you have 3 into, you do 3. So 43 into 3. So 3 3s are 9 and 4 3s are 12. Okay. So we have got a number. So we'll put here 3 and here we'll get 23. So 129. This is 0 0 0. So the square root of 529 is 23. Okay. So in this method you can find the given square root of a number. Now let's look at this one. Find the least number that must be subtracted from 5607 so as to get a perfect square. Also find the square root of the perfect square. So now what you are saying, this number is not a perfect square. So we have to find how much do we have to subtract from this given number so that we get the answer as a perfect square, and then that you have to find the square root of that perfect square. So we have 5, 6, 0 and 7. So same step, 5 is there, so less than that is 2 square. So 2, so come 4 here, so we'll get 1. So you have to put the bars first. Okay. So in this, okay, here we'll take 2 numbers together. Here we have to take 2 numbers together. Okay, so now 56, less than 56, which number do we know? So we have 16, 25 we have, then we have 36, then we have 64, so we have 36 only. So we'll take 36 here. So that is 6 6 correct. Now this will be 0 and this is 2 here. Now these two numbers we have to get them down. So 0 and 7. Now we have to find the square of this number. So 6, if you double, it will be 12 here. Now we have to find this missing number. So 12 into what will give us 2007 or anything less than 2007. So 12 into 122 into 2. So 122, 2 2s are 4, 2 2s are 4 and 2. Next 3 2s are 6, 3 2s are 6, 3, no. Then let's go maybe higher. 6 2s are 12, 6 2s are 12, 13, 6 1s are 6, 7, no. So maybe 8, 8 2s are 16, 8 2s are 16, 17, 8 1s are 8, 9, no. 128 into 9, 9 2s are 18, 9 2s are 18, 9 2s are 18, 9 2s are 18, 19, 9 1s are 9, 10. So maybe even higher we have to go in this case. Okay, so yeah, so into maybe we can go like, okay, we have done one mistake, sorry, one mistake here. So we have to take 1 2 3 into 3. So 3 3s is 9, 3 2s are 6 and 3. 1 2 8 and 8 will take. 8 8s are 64, 8 2s are 16, 17, 18, 19, 20, 21, 22. 8 1s are 8, 9, 10. No. So then 128 into 129 into 9. 9 9s are 81. 9 2s are 18, 19, 20, 21, 22, 23, 24, 25, 26. 9 1s are 9, 10, 11. So 161 we are getting. 1 2 1 1 into will take 1. Or will take 12 here and see. So this will be 12, 12 2 2 4, 2 1s are 2, 2 2s are 4, 2 1s are 2 plus 2 1 2 and 1. So 4 4 5, this becomes 4 and 1 4 1 4 5 4 0, and we wanted 2007, so it should be around, if we do 1 to 10 we will do 0 0 0 0 plus 2 3 4 0 0 plus 0 1 2 1 0 0 1 2 1. No. So maybe I think we have to take this number itself. So that will be 9s are. Take 9 here and this will be 1 1 6 7. Or another thing that we can do here is that we'll take individual numbers and try to solve it, because taking two numbers makes it a huge number. So say we have 5 6 0 7. So 2 2, so this will become 4 here. So we'll get 1 6 0 7 we can get down. Okay. Now this 2 comes here. So this we have to find. So last number is 7 here, and 7 won't come as such in any table. So we'll take maybe 4 into 4. So 24 into 4, 4s are 16, 4 2s are 8, 9. 4 2s are 8 and 9, 96 we are getting. Then 28 into 8, 8 8s are 64, 8 2s are 16, 17, 8 2s are 16, 17, 18, 19, 20, 21, 22. Then 29 into 9, 81, 9 2s are 18, 19, 20, 21, 22, 23, 24, 25, 26. So even higher we have to go. Okay. So here 56007. Okay, so here we missed out one square over here. So if we take two numbers together, what is happening here? They have taken 5 5s is 25, then we have 36, then we have 49. In that case we were missing out 10. So 49 if you take, then you get 70 as the remainder, and then you get 144 into 4. So 74 and 131. So now what the question was, find the least number that must be subtracted from 5607. So if we are taking 5607, in that case we have to subtract this 131 from it. So on subtracting 131 we'll get 5476. Now 5476 will be a perfect square of 74. So when you do long division method, you get both the answers in the problem itself. Okay, when you do the division, you get the answer itself. So if you are not getting a remainder 0 over here, in that case the answer below that you get is the one you have to subtract from the main question, so that you get a perfect square number, and then the number that you get on top is the perfect square of that given number. Okay, next we'll see square roots of decimals. So here we have 12.25. okay, same way we have to start the sum. So we have 4, then we have 9, 2 square, then 3 square, then 4 square is 16. So less than that we have is 9. So 3 and 3 will get 9 over here. So these and this 2. So 9, 10, 11, 12. So 3 and these two numbers come down, 25. So now you have to double this number. So this will become 6. So 6, say 3 into 3. 6 3s are 9. 3 3s are 9. 6 3s are 18. 6 4 into 4. Since it's last 5, so we can try 6 5 into 5. So 5 5s are 25. 6 5s are 30. 30. Okay, so we are getting 325 here. So the number here is 5, and here also we have to put 5, and this becomes 0 0 0. Now here, just right after you get the decimal no down over here, you have to shift the same decimal on top. So the perfect square root of 12.25 is 3.5 here. Similarly, we'll do this last one. So 42.25. So again we can start directly by taking this. So less than this we have, I think, 6. 36 6 are 36. So 36. Now we'll get a decimal here. So 36 if you take, so come 3, 6, okay, 6, and then these two numbers come down, 25. So here what we have got, 325. So 625 you have to find 6. So double will be 12. So 12, which number if we multiply it with, maybe 5. 5 5s are 25, 5 2s are 10, 11, 12, 5 and 6. Okay, so we'll have 5 here and 5 here. So 625. So perfect square root of 42.25 is 6.5. Okay, so we have to be very careful with the numbers that we are using. In this case, the answer was not, we were not able to get the answer because we missed a square over here. So we missed out, this was 5 square, this was 6 square, and here it was 7 square. So in that case 49 was missed out, therefore the sum got stuck over here. So we have to be very careful with the numbers that we use to do the subtraction, and the numbers that square roots that we know. So that was it for this chapter. Please don't forget to like, share and subscribe to the Bodhi Academy.